Hello, everybody, my dear students. We continue our short Python lessons. Today is a super important topic, variables. If statement is a piece of action, a variable is a piece of data. Being a programmer, you have to handle both. You have to handle the logic of your program, the actions. Also, you have to process data. And variables are the simplest pieces of data you can process as a programmer. As you may know, computer has a memory, or we call it sometimes RAM, random access memory, where the actual processing takes place. So using variables, programmer can access RAM cells and can write data into the RAM or read data from the RAM. So technically speaking, variable is just a small named piece of the computer memory or RAM. Any variable has a name, a value, and a type. Programmers responsible for creating names. It's like your variable ID. Value is the actual content of your variable. It may change, by the way. At the beginning of your program, your variable may, if it reflects your age, for example, at the beginning of the program, it may be 19, and then after your birthday it becomes 20. So variable content may change. And also any variable has a type. Type, it's basically category, group of variables, because data can be saved in the RAM in different formats. How do you create a variable? So let's take a look now at the editor. So I need a variable, let's say my name. So you type it, you have to invent good name. Naming is a very important skill because your variables supposed to be not very short, not very long, easy to remember. You associate them with the certain data. And whenever you define a variable, you're supposed to initialize it. So you're supposed to save initial value into your variable, and let's make it my age. And that's how you create a variable in Python and you initialize your variable. If you don't know ahead of time the initial value, well, I think the good idea to initialize with the 0. Now, space is not allowed. You cannot use in your variables names spaces. Also, the first character of the variable name must be a letter. So digits are allowed. You can use digits in the variable's names. However, the very first character must be a letter. Also, if your variable is long, and if you want to separate somehow words, you can use underscore. Underscore is perfect character. It is allowed to use. So technically speaking, I can write my age variable two different ways, like this using underscore and like this using capitals. It's up to you which one you prefer. Of course, names are case sensitive, so be careful. A capital, it's not the same as a small. And be consistent. So if you like this style of the naming variables, then stick to it. If you like this style, which is a little bit shorter, again, stick to it. Be consistent and do not mix those two different ways to name variables in one project. Talking about types of the variables, there are four basically essential or primitive types in Python. We have integer variables or int. We have floating point variables or float. We have strings variables, str, and we have Boolean variables, bool. How do you know the type of the variable? The type of the variable is based on the first initialization. For example, here my age is integer variable because this is integer number. If I initialize like this, I create floating point variable. If I initialize my variable like this, it's a string variable. String, it's a piece of text. Finally, if I initialize a variable like this, let's say my variable name is exam passed, then it's Boolean. Boolean variables may have only two values, true and false. So the variable type depends on the initialization. We can initialize your variables as integer, as floating point, as strings, or as booleans. Let's take a short example. So let me open a very short program like a variables demo. And let me close this window. So what you see here, I declare or define 5 variables. First name variable is initialized to John. It's a string variable. The type is string. Second variable also string. It's Brown. Age is integer variable because it's 25. 25 is integer number. Average Python mark variable is floating point because it's not integer, it has fraction. And finally, I have a variable, it's called honor award. And it's Boolean, and I initialize it to true value. So remember, Boolean variables may have only 2 values, true and false. And then what I do, I print the values of my variables. You see what happens here. By the way, let's turn on the line numbers. So in lines 9 to 13, I just print the values of all 5 variables. So I expect to see when I run my program John, then Brown, then 25, then 88.5, and finally I expect to see true value of honor award variable. So let's save the changes. Let's run it. And that's precisely what I expect. You see, 5 values are printed. Now, true is a so-called keyword. So any computer language has reserved or keywords, special words we can use only for certain things. Programmers supposed to know those keywords. We don't have a lot, maybe Python has around 30-40 keywords, so we should know them at least, and we should avoid naming our variables using those keywords. So stay away from those keywords. True is an example. False is another example of the keyword. Now, obviously, the value of the variable, as I told you, may change. For example, let's say after I process one student, the second student could be Maria Roberts. So, of course, later on, after, let's say, many lines of text, I could save in the same variable something else. So I may replace basically John by Maria and Brown by Roberts. So it's possible. And then if you save in a variable new value, of course, old value is lost, replaced. You never get it back. So the whole statement you see here, and of course at the beginning of the program is so-called assignment. Assignment statement is maybe your number one statement in programming, because what it does, it takes something on the right of the equal sign and it saves it into the variable on the left. So assignment statement works from the right to the left. Data is going from here to here. So you can consider variable as a small container. Let's talk about now literals. They are also pieces of data. So in a way, literals are similar to variables. For example, this is string literal. This is integer literal. This is floating point literal. This is Boolean literal. So literal is explicit data. It's not possible to change it. John is going to be forever John. Number 25, not possible to change. It's always 25. That's why it doesn't really make sense to write commands or statements like this. Literal must not be on the left side of the assignment. It doesn't make any sense. Let me demonstrate. Let me run it. You see, red color, Python is complaining. It doesn't like what I did. So literal can be only on the right side of the assignment, but on the left must be a variable. So I perfectly can write this. If I have two variables, that's fine. I can write this. So variables could be on the both sides of the assignment, but literal explicit data only on the right side of the assignment statement. The interesting thing about Python is not only value of the variable is very dynamic and can change, of course, but the type of the variable also can be changed. So I'm going to show you one more program. And what you see here, let me close the old window. Let me display again the line numbers. So you see very interesting demo because my variable first is integer, line 2. And also I'm using here in this demo very useful library function. We are going to talk about libraries later on. So library basically is pre-written code. Some typical tasks you don't want to do because they are so popular. They are already done for you and they are included into Python library. So type is a library function, and it's very useful because for any variable it can tell the type of that variable. So what I did in line 3, I print. So basically I using two library functions here. First I figure out the type of the variable, then I print it. I want to see it. Then I reassign 99 now becomes 99.99. Again, I print the type. Then my variable becomes string. I type it. Then it becomes Boolean, line 8, and I print it again. So you see, type is quite dynamic. By the way, many languages do not allow this trick. In many languages, variable after it's declared has certain type and you not allowed to change it anymore. Python is flexible. You can not only change the content, the value of the variable, you may also change the type of the variable. So let's run it. Let's save the changes. Let's see what happens. And here we are. First my variable was integer, then it became float, then it became string, and then it became Boolean. So that's exactly what I expected from this program. Sometimes what you want to do is so-called casting. So, for example, you have a variable. It is floating point, let's say salary, floating point variable. And then you want to convert the type of the variable. So you may use also four useful library functions: int, float, str, and bool. So they convert the type of the variable. For example, if I apply str to my so if I apply casting function str to my variable, it becomes a text. So the same number now going to be just a text, a set of characters. If I apply to my variable int casting function, basically I force variable to be integer. So remember, sometimes life is complex. We need to treat variables despite of the fact they are declared as certain type. We need to treat them different way. So that's why we have four casting functions, and they let us convert one type to another. So what happens here, in line number 2, I applied casting function str to my variable and I save it again. So I change not only the type of the variable, obviously I change the content of the variable. Now it's not a number. Remember, type it's format of data. Now it's just 8 characters. So let's save it and let's run it. So you don't see really difference, but it's different. It's different because strings saved in computer memory very differently from the numbers. And if, let's say, I apply integer casting, if I run it again, you see what happens? It's truncated or cut. The numbers after dot, after period, just cut, ignored. Sometimes we call it truncate. And now my salary is integer. It's not floating point. So remember, there are 4 casting functions. Why 4? Because there are 4 types of variables. So let me review what we covered today. We covered variables, we covered literals, we covered assignment statement, very important number 1 statement in programming, what it does, how it works. And we covered variables names, how to create them. We talked about variables values, how they can change, and we talked about variables types. There are 4 types of the variables. You can convert one type to another using casting functions. And also you can see the type of the variable. It's not a secret. And library function type sometimes quite useful if you want to investigate what's going on. You can apply it and Python will show you the type of the variable which may change during the program execution. So thank you very much for listening our next lesson about variables, literals, assignments, types, and I'm looking forward to see you again. All the best. Bye-bye.